Hello everyone, welcome to InfoStream YouTube channel. So in this video, let's discuss how to solve the Hasse diagram problem. So this is part 2, part 1 video link I will give it in description. So what is Hasse diagram means? It is the pictorial representation of poset. So what is poset? Poset means the given set of relation must be satisfying reflexive, transitive and symmetric closures. So if they satisfy all the three conditions, then you can call it as a poset. So in the problem related to Hasse diagram, they will directly give the poset which will be satisfying that condition. So you don't need to again recheck the conditions. So just to start solving the problem. So to solve the problem, we will be using 4 steps. First one is to draw the diagraph. So how to draw the diagraph means? So how to draw the diagraph means here in the given set or the array, what are the elements 1, 2, 3, 4, 12. So you can write them downwards also, you can write them upwards also. So let's write them upwards 1, 2, 3, 4 and 12. So if you see here, I wrote little bit upside. From 1, 2 is up, from 2, 3 is little bit upside. From 3, 4 is little bit upside. From 4, 12 is little bit upside. So like that only you must write. So this is step number 1, designing the diagraph. Now represent the relation in the diagraph. 1 comma 1. So 1 comma 1 means self loop. 2 comma 2, 3 comma 3, 4 comma 4, 12 comma 12. So all will be having the self loop. 2 comma 2, 3 comma 3, 4 comma 4, 12 comma 12. Now 1 comma 2, 4 comma 12. From 1 to 2, 4 to 12. 1 comma 3, 1 comma 4. From 1 to 3, from 1 to 4. Next 1 to 12, 2 to 4. 1 to 12 and 2 to 4. Next 2 to 12 and 3 to 12. 2 to 12 and 3 to 12. Now the first step is complete. What you did? You represented or designed the diagraph. So in the second step, what we must do? Remove the reflexive and transitive edge. So I will tell the step. So step number 2. First let's remove the reflexive. Reflexive means same elements. That is 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, like that. That is self loop must be removed. So all the self loop I must remove from the diagraph. Next, another is I must remove the transitive edge. So what is the transitive edge means? If I consider 3 elements A, B and C. For example, if there is a relation from A to B and there is a relation from A to C. A to B and there is a relation from B to C. If there is a direct relation from A to C also. If A to C is also present, then you can call it as a transitive closure, or this edge will be called as the transitive edge or a transitive relation. So this must be removed. So let's check one by one. 1 comma 1. If you see here, A is 1, B is 1. It must be not be same elements. A must be different, B must be different. So the reflexive will not be considered here. 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 12 comma 12 will not be considered. 1 comma 2. So now let's assign A value as 1 and B value as 2. Now let's see for whether there is a relation. So sorry, this is B comma C. A to B and B to C. So now let's search for C value. That is from B to C there must be a relation. So the relation must start from 2 itself. Whether there is a relation starting from 2? Yes, here. 2 comma 4. So C value will be 4. A value is 1, B value is 2. B value is 2, C value is 4. Now, if there is a edge from 1 to 4, that is relation from 1 to 4, then you can call it as a transitive edge. So check whether 1 comma 4 is present. Yes, 1 comma 4 is here. So there is a transitive edge, I must remove it. 1 to 4 here, I must remove that edge. Next, let's search 1 by 1. So 1 comma 2 is over now. So this is over. 4 comma 12. So A will be 4, B will be 12. So search for the relation which starts from 12. So no relation is starting from 12. So here this is the reflexive. You can't consider that one. So leave that one. 4 comma 12 over. Next 1 comma 3. A value is 1, B value is 3. So search for the relation starting from 3. So here 3 comma 12. So C value is 12. 1 comma 3, 3 comma 12. If there is a relation from 1 to 12, then there is a transitive edge, we must remove it. So search here 1 to 12, it is there. So you can consider A value is 1, C value is 12, there is a transitive edge, I must remove it. So 1 to 12, there is a transitive edge, I am removing it. Next, 1 comma 3 is over, let's search for 1 comma 4. Next one, 1 comma 4. A value is 1, B value is 4. So whether any relation is starting from 4, don't consider the reflexive one. I told earlier only. So there is no edge. So give 1 comma 4. Next 1 comma 12. So A value is 1, B value is 12. Whether there is any relation starting from 12? No. Next 2 comma 4. A value is 2, B value is 4. Whether any relation starting from 4? Yes, here 4 comma 12. So if there is a edge from 2 to 12, then you can consider it as a transitive edge and you must remove 2 comma 12. Here 2 comma 12 is here, so there is a transitive edge from 2 to 12, you must remove it. Next 2 comma 4 is over, 2 comma 12. So 2 comma 12 means there is no relation starting from 12, so leave it. 3 comma 12. So 12 there is no starting, so next is 3 comma 12. There is no relation starting from 12, so you must leave that one also. So now you remove the 3 edges which were transitive, 1 to 4, 2 to 12 and 1 to 12, and reflexive, that is all the self loop you remove. So in the second step you must write the refined or the updated diagraph. So whatever the elements will be left, just write that one, 12, 4, 3, 2 and 1. So from 4 to 12 there is a edge. Next from 2 to 4 there is a edge. 1 to 2 there is a edge. 1 to 3 edge is left. Next 3 to 12 edge is left. So this much will be remained after second step. So now let's move to the third step. So what third step tells? Draw the diagraph where all the edges point upwards. If you see the updated diagraph, all the edges are pointing upwards itself. Whether they may be tilted a little bit, but they are showing upwards. So that is the main thing. If you had written the diagraph from upside to downside, that is 1, 2, 3, 4, 12 like that, you should have written upside down, because you must represent the arrows of the edges moving upwards. So how to decide means, if you see here, why I wrote 1 at the bottom means, here 1 is not having any incoming edge. If there is an incoming edge, you must not write at the bottom. Whichever the element which is not having an incoming edge, that must be written downside. If you see here, 3 is having an incoming edge, 2 is having incoming edge, 4 is also having, and 12 is also having. But 1 is not having an incoming edge. So it is written in the bottom itself. So now here only third step is solved. So let's jump into the fourth step. So the fourth step is remove the directions in the edges. Here these are the directed edges, no? So remove the direction and replace the circles with the dots. Here 12 is enclosed within the circle, no? We must replace it with dots. So this is for 12, 4, 3, 2, 1. How you designed this one, that like only you must write the dots, and the relation will be denoted using the edges, no? So here you must not write the direction of that edge. You must simply define the edge only. So 2 to 4, 12 to 4, 3 to 12, 1 to 3, 1 to 2, 2 to 4. So this is the final Hasse diagram at the step number 4. So what you did? First you draw the diagraph, and after writing the diagraph using the given relation, you remove the reflexive, that is the self loop. Next the transitive edges. So in the third step you wanted to write all the edges upwards. So all were written upwards first only, so you not did the third step. Fourth step was to remove the direction of the edges and simply represent the edge, and the circles will be replaced using the dots. So hope you understood the topic, how to solve the Hasse diagram. So if you have any doubt regarding this topic, please do comment below, and the part 1 video link I will give in description. As many problems you solve, you will be confident in that topic. So you must solve more problems related to this topic. So if you liked the video, please subscribe and support us. Thank you.